Hello and welcome back to St Edmund's Maths. Okay, today we are looking at prime factor form. Now sometimes it is also known as product of primes. Get used to hearing both phrases. It can be in index form, but we'll go through it and show you all the techniques. First of all, quick reminder, prime numbers are numbers which only have two factors, 1 and itself. Okay, now it is worth learning your primes from 2 up to 50. Okay, now obviously 50 is not a prime, but if you can learn all of the primes from 0 to 50, it helps enormously. So to recap, if you want to pause the video and have a go, please do, and then check back in. But they are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43 and 47. And as I say, it's worth remembering between. Now when we're looking at prime factor form or product of primes, the idea is we take a composite number. I'm going to take the number 224 as my first example, and we're going to split it out into its prime factors. Okay, so we're going to split it out into the series of primes that when they multiply together, you get back to this original number. So I'm going to start off with 224. Now it's an even number, so immediately I can pull 2 out. 2 is a prime. How many 2's in 224? 1, 1, 2. Oh, 1, 1, 2 is another even number. I can pull 2 out again. That's a prime. How many 2's in 112? Well, there's 50 2's in 100, 6 2's in 12, so that would be 56. Not a prime, keep going. Even number again, pull another 2 out. How many 2's in 56? 25 and 3, 28. Even number again, pull another 2 out. Oops. Change my colour coding, there we go. How many 2's in 28? 7, no, not 7. How many 2's in 28? That are 14, oh, another 2. Ugh. 27, on a continental 7 for some weird reason. Oh well, so let's have a look. So we've got 2 times 2 times 2 times 2 times 2 times 7 gives us 224. So 2 times 2 times 2 times 2 times 2 times 7. There are in fact 1, 2, 3, 4, 5. And because we are lazy mathematicians, in order to get the full marks, we know that we're multiplying 2 by itself 5 times, multiplied by 7. There's the first example. Okay, let's do another example. Move that over so you can see clearly. I'm going to take the number 1, 2, 2, 5. Now they will give you these numbers on the question paper. 1, 2, 2, 5. Can't do 2 because it's not an even number. But it's got a 5 on the end, and because it's got a 5 on the end, I know that I can pull that 5 out. Okay. How many 5's in 1, 2, 2, 5? Now I'm going to find that too tricky to do in my head, so I'm going to do a jotting. Please note that I have put the jotting next to the question, so it's nice and clear. How many 5's in 1? 0, carry the 1. How many 5's in 12? 2, carry the 2. How many 5's in 22? 4, carry 2. How many 5's in 25? 2, 4, 5. Okay, that's a prime, so that's that branch finished. Oh, no, it's in another 5. Let's pull the other 5 out. Okay, Again, can't do that in my head. 2, 4, 5, so I'm going to do it on paper, little jotting. How many 5s in 2? 0. How many 5s in 24? 4. Carry 4. How many 4s in 45? 9. 49. Okay, so it's not even. 4 plus 9 is 13, so it can't be in the 5s, doesn't end in a 5. 7, of course, because 49 is a square number. 7 and 7. 512 squared times 712 squared. Now this actually leads into a nice little aside. Now before calculators were readily available, this method was used to find the square root of numbers. If we take, oh sorry, that is your answer, but this is just an aside. If we take that 5 squared, we know that we can write it as 5 times 5. And we know that 7 squared can be written as 7 times 7. Under the commutative law, we can swap round the position with multiplication and addition. So we can change that into 5 times 7 times by 5 times 7, which means we've got the same number here multiplied by the same number here. So we can say the square root of 1225 gives us 35. And as I say, it's just a little aside of how things used to be. Occasionally it does crop up on non-calculator papers as an interesting point worth mentioning. Okay, I'm going to give you 2 examples to do, and you will need to work them out yourself. So 450, and can you also work 3, 5, 2, 8. Again, pause the video, work out your answers, check back in. Okay, so 450. I'm going to pull out 10 because it's nice and easy. Neither of those are primes. I can branch this. Also worth noting at this point, it doesn't matter which way round you do this, which method you do this by, as long as you keep going until you get the primes at the end. 10. 2 times 5 is 10. Both of those are primes. 4 times 9. 5 times 9 is 45. 5 is a prime. 9 can be split 3 times 3. So we've got 2 times 3, and there's 2 3s times by 5. Here we go. 2 times 3 squared times 5 squared. Okay, same principle again. Let's see what we can pull out first of all. Okay, well, it's an even number, so I'm going to pull out 2. Again, I don't know this off the top of my head, so I'm going to do a jotting. Now, some of you will be able to do this mentally, which is absolutely fine. Some of you will have a series of jottings. Again, absolutely fine. Doesn't matter. How many 2's in 3? 1, carry 1. How many 2's in 15? 7, carry 1. How many 2's in 12? 6. How many 2's in 4? 4. 1, 7, 6, 4. 2 is prime. Another even number. Split it again. 2's into 1, 7, 6, 4. How many 2's in 1? 0, carry 1. How many 2's in 17? 1, carry 1. How many 2's in 16? 8. How many 2's in 4? 2. 8, 2, 2. Oh, make sure you copy the numbers over correctly, Mrs. Powell. 8, 8, 2. 2's a prime. Same principle again. Oh, 2. Right, I can do this mentally. 4, 4, 1. are a bit trickier now. Well, it's not an even number, so it can't be 2. I can use my divisibility laws. 4 plus 4 plus 1 is 9. Therefore, it must be divisible by 9. 4, 4, 1 divided into 9. How many 9s in 4? 0. How many 9s in 44? There are 4. 30. 4 9s are 36. Leaving over 8. How many 9s in 81? 9. 9 and 49. Okay, 9 splits into 3 and 3. 49, I remember from before, splits into 7 and 7. Whoops, sorry, just knocked my camera. I do apologise. Okay, so there we go. There's our first couple of marks done. Sorry, leave it in shot so you can see what I'm doing. So we've got 2, 1, 2, 3 to the power 3 multiplied by 3 to the power 2 multiplied by 7 squared. Prime factor form.